Alright, this is 7.2.2, finding voltage and current in a specific resistor. So do problem number 1, 2, 3, and 4, and you guys will do numbers 5 and 6 on your own. So number 1 says find the voltage and current through R3. So we have 3 resistors in parallel, and we're going to be looking for the current and voltage through R3. So because these 3 are in parallel, the voltage is going to be 6 volts through each branch. So 6 volts through R1, 6 volts through R2, and 6 volts through R3. So to find the current in R3, all we need to do is voltage through 3 equals current through 3 times resistance through 3. So since we said our voltage is the same through each branch and it's 6 volts, it's going to be 6 volts equals I3 times R3, which is 13 ohms. We take that, I3 equals 6 volts divided by 13 ohms, and I3 equals 0.46 ohms. So that's our current through 3. Like we said before, our voltage through 3 is 6 volts, the total voltage in the circuit. So that would be our answer for problem number 1. Now for problem number 2, it says find the current and voltage in R2 this time. This time, these 3 resistors are in series, and in series the current stays the same as you go throughout the circuit, but the voltage changes across each resistor. So in this one, first thing we're going to have to do, in order to find the total current in the circuit, we're going to have to find the total resistance first. One thing I forgot to write down here is voltage is 24 volts in the circuit, but our first step, and that voltage is 24 volts, is given in the problem. Our first step here is going to be to find RT. So our total or equivalent resistance is going to be equal to 6 ohms plus 21 ohms plus 9 ohms. So that is going to end up equaling 36 ohms for our total resistance in the circuit. So now we're going to find the total current in the circuit using V equals IR. Let's say V total equals I total times R total. So we get 24 volts equals I total times 36 ohms. And our total current in the circuit is equal to 0.67 amps. So that is our total current in the circuit. Now, our last step on this problem is to find the voltage across R2. And again, that's the total current in the circuit, and that equals the total current in R2 because we have 0.67 ohms through R1, 0.67 ohms through R2, and 0.67 ohms through R3. That's what that means. So now we're going to say the voltage across 2 equals the current through 2, which, like we said, is the total current in the circuit, times R2. So that ends up equaling 0.67 amps for our current through R2, times the resistance of R2, which is 21 ohms. And when we solve that, we get our resistance, or our voltage across R2 is 14 volts. So answers to this problem, the voltage in R2 is 14 volts, and the current in R2 is 0.67 amps. Alright, go on to number 3. This one's a little bit more, a lot more complicated than the first two. So in this one, we want to find the voltage and current in R3. What we're going to have to do is we're going to combine 3 and 4, 2 through 4. We're going to combine 5 and 6 in a separate, or 6 and 7, I'm sorry, in a separate area, and then combine the whole thing. And actually, we're going to start with 6 and 7. Because what we want to do when we do a problem that's kind of complicated like this, to make it easier to find the voltage and current in R3, we're going to keep everything that R3 is part of together. So we're going to do 3 and 4, 2 through 4, 1 through 7, all in one place because R3 is part of those. But we're going to do R6 and 7 separately because we're not going to use that when we calculate the current and voltage through R3. So what we're going to do is go through and find the resistance of 3 and 4, 2 through 4, the total resistance, and then go back through and find the current and voltage in each branch as needed. Alright, so let's do this one. So the first thing we're going to do is combine 6 and 7, and they're in series, so we're going to say R, I don't want to use red, I'll use black. R 6 through 7 is equal to 5 ohms plus 8 ohms, since they're in series, and that equals 13 ohms. I'm going to shrink that down a little bit, so we need the space. Or we'll just keep it there. Now, our next step is going to be to find R3 and R4, the combination of those two, and they're in parallel, so we're going to do 1 over R3 through 4 equals 1 over 12 plus 1 over 5, and when we do that math, we should get that R3 through 4 equals 3.53 ohms. See if I can shrink that one down here. There we go. Next, so we've combined 3 and 4. Our next step is going to be combine 2 through 4, and we're going to keep all those right here because 3 is part of those. So those are in parallel, or in series. R2 is in series with R3 and the combination of R3 and R4. So we're going to say R2 through 4 equals 24 ohms plus what we just found for R3 through 4 of 3.53 ohms. When we do that math, we get 27.53 ohms. And we get R2 through 4 as that. So next, we're going to find we're going to find the total resistance of 2 through 7, and that 2 through 4 is in parallel with 6 and 7. So we're going to say 1 over R2 through 7 equals 1 over 27.53 plus 1 over 13. And we do that math, we should get that R2 through 7 is equal to 8.83 ohms. Our last one, to find the total resistance, we're going to say R total is going to be 1 combined with 2 through 7, and those two are in series. So we're going to say R1 plus R2 through 7, so 18 ohms for R1 plus 8.83 ohms for R2 through 7. And we do that math, we get the total resistance is equal to 26.83 ohms. Check that one down. Oops. So now we have the total resistance. Our next step is going to be to find the total current in the circuit. So we're going to find the current flowing through the whole circuit, the current coming out of the battery, and it splits up here, but then it comes, and that's the same as the current going back into the battery. So we're going to say total voltage equals total current times total resistance. And we have our total voltage is 30 volts equals our total current, which is what we're looking for, times our total resistance, which is 26.83 ohms. And we do that math, we should get I equals 1.12 amps. So that gives us the total current in all parts of the circuit. Now, because the total current flowing through R1 is equal to 1.12 amps, and the total current flowing through R2 through 7 through this whole piece right here is 1.12 amps. So because they're in series, we know that the current is the same through both, and it stays the same as the current in the whole circuit. So we know that the current through 2 through 7 is going to be 1.12 amps. So we're going to use that and the total resistance in 2 through 7 to find the voltage drop from here to here across 2 through 7. So we say voltage 2 through 7 is equal to I 2 through 7, which we just found to be 1.12 amps, times the resistance of 2 through 7, which we found earlier to be 8.83 amps. So we do I is 1.12 amps, R 2 through 7 is 8.83 ohms, and we do that math, we should get our voltage from 2 through 7 is 9.9 volts. So it's going to go right there because that's what we use there. Now we've got that voltage across here is 9.9 volts because this top branch and this bottom branch are in parallel. It's the voltage through the top branch, so the voltage through 2 through 4 is 9.9 volts, and the voltage through 6 and 7 is also 9.9 volts. We want to deal with the voltage across this top part because that's where R3 is. Now we're going to use that voltage. So the voltage of 2 through 4 equals the current of 2 through 4, which is what we need to find next, times the resistance of 2 through 4. So we got 9.9 volts equals I of 2 through 4 times 27.53 ohms, and we get I of 2 through 4 equals 0.36 amps. I'll shrink this down, put it right there. So now that is the current through 2 through 4. So that's the current through this whole top part here. And because R2 is in series with R3 and 4, the current through both of those is going to be 0.36 amps. So now we need to find, since we have a parallel part here, the voltage drop will be, start over. Since these are in series, we need to find the voltage drop across each. So we're going to find the voltage drop across 3 and 4 using the current we just found, I current 2 through 4, because that's the current through 3 and 4. So we're going to say voltage 3 through 4 equals I 3 through 4, which is 1.36 amps, times the resistance of 3 through 4, which we found earlier to be 3.53 ohms. If we do that, we get 0.36 amps times 3.53 ohms, and our voltage of 3 through 4 equals 1.27 volts. So now that, I don't know why this ended up in two pieces here. Now that is our voltage through 3 and 4. Because voltage stays the same in parallel, that's the voltage through R3. So that's one of our answers, is our voltage of 1.27. So that's the voltage through R3. Now our last step is going to be finding the current through R3. So we're going to use the voltage we just found of 1.27 volts and the resistance of 12 ohms for R3, and we're going to use that to find the current through R3. So we're going to say V through 3 equals I through 3 times R through 3. So when we plug our numbers in, we get 1.27 volts equals I3 times R3, which is 12 ohms. And we do that math, we get the current through 3 equals 0.10 amps. And so that is our last part, and somehow that red line got grouped with those things. Where's my eraser? I'll erase that. Or not. So our answers to this, though, are the voltage through 3 is 0.1 amps, and the voltage through 3 is 1.27 volts. So those are the two answers you're looking for in this problem. Alright, and if you notice here, we went back, we used the total current and this part to get 9.9 volts. Then we used 9.9 volts and that resistance to get 0.36 amps. Then we used 0.36 amps and that resistance to get 1.27 volts. Then we used 1.27 volts and the resistance of 3 to get that. And you notice that the currents kept getting progressively smaller and the voltages kept getting progressively smaller. And that should happen when you do this. Alright, I'm going to do another example of one of these problems next, and that's number 4. Says that we're looking for the current and voltage in R3 again. So we're going to use the same process. This time, R3 is going to be a part of everything, so what we're going to find first is we're going to do 2 and 3 in parallel, then 2 through 5, or I'm sorry, 2 and 3 in series, 2 through 5 in parallel, then 1 through 5 are the total in series. And R3 is part of all of those, so we're going to include all those in the list we make here. So first thing, 2 and 3 are in series, so you're going to say R2 through 3 equals 13 ohms plus 7 ohms, so R2 through 3 equals 20 ohms. Next, we'll do R2 through 5. So, and the 2 and 3 are in parallel with 4 and also in parallel with 5. So we're going to say 1 divided by R2 through 5 equals 1 divided by 20 ohms plus 1 divided by 19 ohms plus 1 divided by 17 ohms. And we do that math, we get R2 through 5 equals 6.2 ohms. I'll shrink that down. And now our last step for finding the total resistances is find the total resistance, and R7 is in parallel with this, or I'm sorry, R7 is in series with this whole thing. So we're going to do R total equals R1, which is 7 ohms, plus R2 through 5, which is 6.2 ohms. When we add those together, we get 13.2 ohms for the total resistance of that circuit. Spread these out a little bit. So now, we're going to do kind of the same process we did before. So we're going to use V equals IR with the total resistance and the total voltage to find the total current in the circuit. So we're going to do VT equals IT times RT. And we get 27 volts equals IT times 13.2 ohms. And we get IT is equal to 2.05 amps. So that is our total current in the circuit, and that's the current flowing through R1 and the total current flowing through the whole combination of R2 through 5. So now we're going to use that current, which is the current flowing through this whole thing, and the resistance of this whole thing to find the voltage across this whole thing. So we do V of 2 through 5 equals I of 2 through 5, which we found to be 2.05 amps, times R of 2 through 5. And so we've got current through 2 through 5 is 2.05 amps, times the resistance of 2 through 5 is 6.2 ohms. So the voltage of 2 through 5 equals 12.7 volts. So now we're going to use that 12.7 volts as the voltage through that top branch, the voltage through the middle branch, and the voltage through the bottom branch. But we're really only concerned with the top branch because that's what R3 is part of. So the voltage through this top branch is 12.7 volts. Now we got to find the current through that top branch. We're going to do voltage through the top branch, so voltage of 2 through 3, which we said was 12.7 volts, equals the current of 2 through 3, which is what we're going to be finding, times the resistance of 2 through 3, which is 20 ohms. So we plug our numbers in, and we get voltage of 2 through 3 is 12.7 volts equals I of 2 through 3, which is what we're finding, times R of 2 through 3, which is 20 ohms. And we get I2 through 3 equals 0.64. Try writing this again here. 0.64 amps. Let me shrink that down, bring it up there. So we found here is the current across this whole top branch is 0.64 amps. And because 2 and 3 are in series, that means the current through 2 is 0.64 amps and the current through 3 is 0.64 amps. So our last step is to find just the voltage across 3. We have the current through 3 and the resistance of 3. So we're just going to use V equals IR. So voltage across 3 equals current across 3, or current through 3, times resistance of 3. So we get 0.64 amps times resistance of 3 is 7 ohms, and that ends up equaling 4.48 volts. So now we found our answers here. So the current through 3 is 0.64 amps, and the voltage through 3 is 4.48 volts. And again, that's because the current across 2 and 3, the current across 2 is 0.64 amps, and the current across 3 is 0.64 amps. We use that to find the voltage across 3, which was 4.48 volts. Right, do the last two problems on your own. The answer should be at the end of the problems. We'll answer any questions when I get back on Tuesday, hopefully.